When dye transfers from a brightly colored fabric onto another surface through simple friction, it ruins both materials. In the textile industry, testing a fabric's resistance to this color transfer is a strict requirement before a product goes to market. This is the international benchmark for quantifying that resistance, ISO 105-X12. It details the precise methodology for testing color fastness to rubbing. To perform this assessment accurately, an operator must master two distinct physical procedures, the dry rub and the wet rub, and learn to grade the resulting color transfer using a standardized grayscale. Executing this exact methodology is what separates a reliable, high-quality garment from one that causes a massive, costly product recall. We start by preparing the test specimens. You need to cut two pieces of the fabric, measuring precisely 50 by 140 millimeters. One must be cut parallel to the warp yarns, and the other parallel to the weft. Next, cut to standardized, undyed cotton rubbing cloths. These need to be 50 by 50 millimeter squares. Once the materials are cut, look at section 5.3 of the standard. Both the test specimens and the cotton rubbing cloths must be conditioned in a standard atmosphere, defined by ISO 139, for at least 4 hours prior to testing. Skipping this step introduces latent moisture variations into the fabric. If the baseline humidity of the materials is inconsistent, the friction dynamics will change, completely invalidating the test results. With the samples conditioned, we secure the test specimen flat against the baseboard of the rubbing machine. Place a piece of abrasive paper underneath it to guarantee the fabric doesn't slip during the test. The machine uses a rubbing finger to apply friction. Select the correct shape based on your fabric. For standard textiles, use the 16 millimeter cylinder. For pile fabrics, use the rectangular crock block to prevent heavy color staining around the edges, known as haloing. Regardless of which finger you use, the device applies a constant downward force of 9 newtons onto the fabric. The machine then drives the rubbing cloth across the specimen along a 104 millimeter track. It moves at a rate of 1 cycle per second, 10 times forward and 10 times back, for a total of 20 straight-line rubs. By locking in the exact physical force and track speed mechanically, the standard removes the physical variables of human hands, making the results globally reproducible. For the wet rubbing test, the physical motion is identical, but the moisture control is incredibly strict. Start by weighing a dry, fully conditioned rubbing cloth. Soak that cloth in distilled water. Then squeeze or wring it out until its water take-up is strictly between 95 and 100% of its original dry weight. As highlighted here in section 6.3, verifying this specific take-up percentage is a mandatory step before you run the exact same 20-cycle mechanical rubbing procedure we used for the dry test. Once the wet rubbing cycle is complete, carefully remove the damp test cloth and leave it to air dry at room temperature. Adhering to that 95 to 100% moisture window ensures consistency. If the cloth is too dry or too soaked, it alters the solubility of the dyes and skews the severity of the color bleed. Once your test cloths are ready to be evaluated, place exactly 3 layers of clean white rubbing cloth directly behind each tested piece. This provides an opaque, consistent background. Place the backed sample inside a standardized lightbox. Then, visually compare the stain on the test cloth against the official ISO 105A03 staining grayscale. You assign a numerical grade based on which gray swatch best matches the contrast between the clean cloth and the stained cloth. A rating of 5 means 0 color transfer occurred. A rating of 1 indicates severe bleeding. The grayscale removes personal opinion from the evaluation. It converts a visual perception of damage into a rigid, defensible metric. Generating that numerical rating is the goal, but the evaluation is only complete when the data is formatted into an official ISO-compliant test report. Section 8 details what must be recorded. Reference to ISO 105-X12, the finger and downward force used, whether it was a dry or wet test, and specific water take-up. Finally, record the mounting direction, warp, weft, or oblique, and the final grayscale rating. Executing the physical methodology perfectly and documenting those variables meticulously builds the data that manufacturers rely on to verify the safety and durability of the global textile supply chain.